You know that struggle of, like, sitting on an overstuffed suitcase?
Oh, yeah. Bouncing on it to force the zipper shut.
Right, exactly. Bouncing on it, sweating, just trying to get the thing to close. Well, imagine doing that, but instead of packing clothes, you're trying to pack the entirety of human knowledge into a tiny digital box.
That is quite the visual.
Yeah, so that is the essence of the notes you sent over on the Hutter Prize. It is this 500,000 euro competition, and it challenges researchers to take a 1 gigabyte slice of English Wikipedia.
The ENWIK 9 data set, right?
Exactly, ENWIK 9, and they have to compress it losslessly. So our mission for this deep dive today is looking at how shrinking a file size isn't just, some neat storage trick.
Right. It is actually a verifiable mathematical proxy for measuring artificial general intelligence.
Okay, so wait, how does packing a digital suitcase translate to machine intelligence? I mean, that feels like a huge leap.
It does, but it really comes down to this concept called Kolmogorov complexity. So instead of measuring intelligence by, say, how many facts a system can just memorize.
Like a trivia bot.
Yeah, exactly. Instead of that, Kolmogorov complexity measures it by finding the absolute shortest computer program needed to reproduce a specific output.
Okay, so smaller is smarter.
Right. It ties into Marcus Hutter's AIXI model. And that model basically argues that true intelligence is essentially perfect prediction.
Uh-huh.
If an AI deeply understands the fundamental rules of grammar, logic, and physics, it can predict the text perfectly.
Because storing those fundamental rules takes up way less space than storing millions of raw facts.
Exactly.
Okay, that actually makes perfect sense. It is kind of like, well, knowing a best friend so well.
Oh, yeah.
Yeah, like you don't even need to read their huge, long-winded text message to know what they're saying. You can just predict their response with a single emoji because you understand the rules of their personality.
That is a brilliant analogy.
But, I mean, the organizers are claiming this is equivalent to passing the Turing test. Is predicting Wikipedia's text structure truly the same as conscious human thought?
Well, functionally speaking, if a system can perfectly compress the vast diversity of human knowledge that we have on Wikipedia, it must have built a deeply sophisticated internal model of how reality works.
So it is not just pattern matching.
No, it is actually deducing the laws of the universe from text.
Mm.
In this context, compression literally becomes comprehension.
Okay, if predicting text is the ultimate goal here, why hasn't a massive model like, GPT-4 just completely crushed this competition already?
That is the million-dollar question, or, well, the €500,000 question.
Right. And before we get to why the tech giants haven't swept this prize, I do want to make a quick note on applying today's models. If you are looking to integrate cutting-edge AI into your own world, you really need EmberSilk.
Oh, definitely.
Yeah. Whether you need help with AI training, automation, software development, or just uncovering where agents can make an impact for your business or personal life, check out embersilk.com. So back to the massive AI models. What is stopping them?
Well, the contest has this brilliant catch, and it strictly enforces Occam's razor.
Which is the simplest solution is usually the best one.
Exactly. The catch is that the decompressor software itself actually counts toward the total file size.
Wait, seriously?
Yes. And the whole thing must run on a single CPU core with highly limited RAM.
Oh, wow. So if the decompressor counts toward the size, that means you can't just, hide a massive 100-gigabyte neural network inside the submission code.
Right, you cannot cheat. The intelligence has to be inherently lean.
You literally can't just throw brute force supercomputers at the problem.
No, it forces researchers to build these perfectly elegant algorithms instead. And it is amazing to see how brilliant human minds are solving this.
Have there been major breakthroughs recently?
Yeah, innovators like Saurabh Kumar and Ardmi Margratov are scraping out these hard-won 1% improvements.
There's 1%.
I know it sounds small, but they earn a €5,000 payout for every percent. They're using techniques like context mixing.
Context mixing, how does that actually work under those super strict hardware limits?
So it works by running dozens of different, highly efficient prediction algorithms simultaneously.
Okay.
And then the system dynamically weights the ones that are most accurate for the specific type of text being processed at that exact millisecond.
That sounds like this incredibly intricate dance of mathematical efficiency.
It really is.
It is so cool because while this whole toy regime sits completely outside the mainstream scaling laws of deep learning, it remains this beautifully objective, open-source beacon of algorithmic purity.
It really does, and I think it points us to a really provocative thought for you to mull over.
Oh, what is that?
What if the key to the ultimate world-changing AI isn't building a bigger, power-hungry brain, but an elegantly efficient one that grasps the universe's patterns with absolute simplicity.
Man, what a brilliant concept to leave you with. If you enjoyed this deep dive, please subscribe to the show. Hey, and leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.
And just remember, human curiosity has this boundless capacity to decode complex problems. We are constantly finding fresh, ingenious ways to understand our universe, and honestly, the future of technological progress is just incredibly bright.